Oh, the purpose of this video is to provide you with a full solution of the factors problem as stated in class. Your job is to follow along with this video and to review and to complete the factors class and to complete a test class that will verify that this particular factors class actually does what is expected. Now, what I've done to begin with is I've copied the information from the expected output just as a multi-line comment. Notice the multi-line comment starts with slash asterisk and ends with asterisk slash. These statements will be ignored by the compiler. Now I've modified the output just to make sure it's nice and neat and fits on 2 lines, okay, for each actual test. So the first thing that I'm going to do is I'm going to look at this output and I'm going to examine it. And I'm going to make sure, please ignore that. I'm going to make sure that I come down and I modify. I'm going to paste this example, make this a single line comment, just slash slash. I'm going to make sure that I modify this output such that this output of the toString actually matches exactly that of this example, just to practice some string concatenation here. Okay, so it looks like has 14 factors is on the first line, and then I say factors of the number given on the second line. So here it looks like I start a new line and I'm concatenating the value along with the next string is a prime number and has, and it looks like I need to move this statement up to the previous line, and I need to remove this new line just in front of factors so that the new line will actually begin after factors. And now I'll make sure that I enclose this in double quotes. The escape character has to be enclosed in double quote. I'm going to concatenate this arrow just after I add factors of, and I want to make sure that I concatenate the actual value in here on the second line as well. So it should read factors of 192, in this case factors of the value space, need another concatenation, a plus here, the string dash dash greater than plus all of the factors, and then the close bracket here. Okay, so I'm going to just copy this from the true is prime number portion, and I'm going to paste it down in the else portion, and I'm going to say is not a prime number. And the rest of this should be printed similarly to the previous, I guess, portion of this if statement where, if the number is prime. Okay. All right. So you can pause the video here and update this. We'll test this and make sure that the output is correct when we complete. So I'm going to scroll back up, or correct, not just complete, but correct. All right. When I first construct this, okay, this particular object, I'm going to have to provide an integer v. The sole job of the constructor, which has the same name as the class, is to initialize all the private data. In this case, we only have one integer value, named value. So I'm going to assign the value provided on input. I'm going to assign that to value. In the set value method, The set value updates the instance variable value as well. So likewise, this one says value is equal to, but the input here is not v, but is an integer with the name of num. So I'm going to use the variable name num here. Okay. Next, the count factors method. This method should count all the factors of the instance variable and return that count. Well, that count will be an integer value. So when I do a count factors, according to what we discussed as an algorithm in class, we want to start this loop at 1 and we want to go all the way until value and include the value when we're actually counting. So the way that I start this loop, remember all loops have 3 portions: an initial value. So in this case, the initial value, I'm going to call it I, the variable I, but my initial value is I. My initial variable name is I, and the initial value is 1. Okay, so the loop will start with the integer 1. And I want to make sure that we continue to loop as long as that integer value I is less than or equal to. I want to make sure I include the value itself in my loop. And I'm going to increase by 1 each iteration. So I can do I is equal to I plus 1. And in the next loop example, I will use I plus plus, or the unary operator I plus plus. Okay, so the test that we have to actually conduct for each iteration of the loop, as I changes, I will be changing from 1 and increasing by 1 until we reach value. And the test that we have to actually conduct is a simple test, and we're just going to check to see if the value modulus I, if the result from this operation is equal to 0. Remember, we can use equal with any primitive values. That's int, double, character, or boolean. And if this is true, I want to execute something very simple. I just want to say count plus plus, or another way of asking or making this statement is count is equal to count plus 1, semicolon. So this is the one statement that will execute if and only if the value modulus I is equal to 0, which means that value divided by I, which will be going from 1 to the value and including the value, if the remainder is equal to 0. The remainder operator, modulus. Okay? And once this loop completes, that should add 1 and count each of the values of I that evenly divides value. Okay? Now, once our return count, this method should be complete. We can move on to print factors. And notice that print factors is a void method. It will not return an actual value of any sort. Okay, but nonetheless, if we want to print each of those, we have to write a loop that has a similar behavior. So I want to start integer I is equal to 1. Now I'm redefining I in this loop, but notice that I will only be valid inside of this for loop and will not be visible outside of this for loop. So that's the only reason why I can redeclare I here. Okay, or reuse I. Let's say I'm going to reuse a variable name I. So I has to be less than or equal to the value. And again, I'm going to use a shortcut operator here, or the unary operator I plus plus, which will add 1 to the actual value of I for each iteration at the conclusion of each iteration. So I'm going to also come up, the if statement is going to be very similar here. But instead of actually adding 1 to the count, I am going to just print this statement, I concatenated with is factor of value. So this I will be changing on each iteration of the loop, each iteration of this particular loop. And if value modulus I is equal to 0, then it will print this to the screen. This is an explicit return statement at the end of the for loop. It is not necessary. The purpose of me including it here is I want to demonstrate that you can use the return to end a function that is void. You will always end any execution of a method when you hit the return statement. So here I want to return at the conclusion of this for loop when I've actually already printed out each value of I that is a factor of value if and only if the value modulus I is equal to 0. That will print the factors to the screen using systemout.print. Okay, notice it's print, not print line, which means that they'll print to the same line. The list factors. Okay, this is probably, in my opinion, the more complex of the three loops. But nonetheless, the three parts of the loop are the same. I is going to be equal to 1 to begin. And I'm going to make sure that we continue as long as I is less than or equal to my value. And then I will add 1 I plus plus to my counter each time through the loop. And I'll ask the same if statement. If the value modulus I is equal to 0, but this time I'm not going to add 1 to count. I'm not going to print them to the screen. I'm just going to concatenate this number to this string output. Since the list factors returns a string, since this returns a string, I will simply concatenate, and I'm going to use the shortcut operator output plus equal that adds the current value of output to whatever I ask to concatenate here, and I'm going to concatenate the value of I plus a space. Okay. Now, once this loop completes, you should have a new concatenated value of output, and I'm going to return that string. Just for note-taking sakes, I do want to at least demonstrate that I could also do output is equal to output plus I plus a space. Okay, I've commented this out with a single line comment, but this statement would achieve the same goal if you just simply substitute that in for the statement that's just above it here. Okay, get used to seeing the shortcut operator. It's pretty commonly used. Okay, now the isPrime method, as discussed in class, if a number has only two factors, as 53 does in the example, we will say is a prime number. So we're writing this function or method named isPrime that will simply use the private data, okay, in this class to make that determination. Well, we're duplicating a little bit of value effort here, simply because we actually have a method that already counts the factors here. So if we call the count factors method, okay, I'm going to copy this and I'm going to come down and I'm going to add this, and I'm simply going to do a return count factors equal to 2. If that number is anything other than 2, this method will return a false. If it is exactly 2, is the only time when it will return true. So now, given the modifications to the toString and the modifications to all the other loops, I should be able to compile this, and you should get no syntax errors down here for this particular class. Go ahead and close this, and you want to create a new class called test factors, and we want to test it with those 3 numbers. So I'm going to instantiate one object here named F1, and I'm going to call factor, instantiate it with the number 192, and I'm going to systemout.println F1. Remember that whenever you do a systemout.println or you print any way, any sort of an object, it will default to execute the toString method. So when I execute this statement, it will come over to the factors class and execute this actual toString method and all of its actual logic that's stated here. And it will return a string. So similarly in math, when you have substitution, instead of having F1 here, it will substitute in a string and print that to the screen. Now, there are more than one way to do to complete the rest of the test. I'm going to use the set method. So f1.set. Well, I can't remember. If you ever forget, you have to spell it exactly like I've set it over here. Specified as the programmer, I'm in control here. So it's called set value. Okay. So I'm going to come over and I'm going to say f1.set value. And I'm going to pass in 144, which is my second test value. And then I'm going to do a systemout.println of F1. And that should execute the toString again for me. I'm going to say F1.set value with 53. And then I should be able to do a systemout.println of F1 again. If I compile this, it should be compiled with no errors. If I close this and I right click and execute the main method, and you're doing okay, I should get this exact output, which I was expecting. Okay. Good luck. Code this solution, test it, and make sure that you can generate this exact output. Thank you.